A new topic. That means a new short interview here. And joining me on stage again is Bert Weckhuysen. And this time, Bert brought something to the stage. It looks like a giant pile of balls, but there must be some explanation for this.
Yes,
Let's
correct.
Please reveal what did you bring?
So I brought
us?
some catalyst particles. So these are metals which are dispersed on what we call an oxide, a support.
Yeah.
And when
what is dispersed? Broken down, or?
I will explain because
okay.
Dispersed means that you make it very, 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 very small, so that it is tiny. And tiny is what I mean here. This ball is about it's the size of 10 to the minus 9 meter. So it's very, 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 very small.
Yeah.
So what you need, and that brings us to the title of light. You need like glasses, but then very, 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 very good glasses to be able to see this. And when you're able to see this, you can then even use, for example, CO2 that lands on this surface of this metal nanoparticle. And you can have, for example, hydrogen, which you make from water electrolysis. Yeah. And then from this, you can have a new fuel molecule or something else which grows from this. So what we are trying to do is to understand what is going on at a level of atoms and molecules. We make movies, and with these movies, we want to understand how catalysis works. So that's actually using light.
Yeah.
And on top of it, we want to use light to even catalyze reactions. So you can think about today, there was something about making oxygen on Mars. So what you can do is, okay, how can you do this? You need sunlight, in this case, sunlight on Mars, and then try to do chemistry. But this kind of principles we want to apply to make the refiners of the future, which will be not anymore, at least not completely based on crude oil or fossil resources. Yeah. We want to use CO2, we want to use municipal waste, plastic, and so on.
And do you have any breakthroughs at this moment you can present for us?
What we have been doing in the last couple of years is to make for this Co2 hydrogenation, so this molecule CO2, and which lands here in the hydrogen, we have been able to understand it fully from a mechanistic point of view. And with this, we are able to tweak what can be made. And that you can do what we call thermocatalysis, but you can also do it in water, not anymore making hydrogen, but right away from CO2 in the water, try to see if you can make such hydrocarbon. Both things we have been doing, and I think it's nice that you can use light to understand it better.
Great. So in a few moments we will have the high-speed lecture,
yes.
This time given by Eline Hutter and Mirjam de Graaf. I can imagine that you're looking forward to it.
Yes,
Do you want to add something to the discussion we will have on the talk show table later on? What will be the most important thing we have to talk about?
I think that we have to try to see is, well, this is a metal nanoparticle. It's very concrete, you can say, but I think we should really think in terms of, see, nature has made very complex materials which can do reactions under really simple conditions. Can we get some inspiration from nature? Question mark, and I hope the answer is yes. Yeah. And secondly is, can we then make superior materials which allows us to go for this energy transition?
I will write them down on my cards. Thank you very much for this introduction, Bert.